All right, beginning our next and last lesson in this topic about systems of equations and inequalities, kind of bringing it all together today to look at solving systems of both of equations and inequalities. So for a warm-up, we're going to do 1 and 2 together, then I'm going to let you try 3 and 4, make sure you can get the proper answers on your own on those. So we're just wanting to determine if the point 17 is a solution. So we're just going to plug in x is 1, y is 7 to both of those and ensure that we get the correct answer. So for the first one, 4 times 1 for x minus 7 for y equals -3. And if we simplify that, we get -3 equals -3. So it works for that one. And then we got to try it for the second equation. -2 times 1 plus 7 for y equals 5. And if we simplify that, we get 5 equals 5. So that is also true. So yes, 17 is a solution for number 1. And then if we do the same thing for 2, number 2 is an inequality, you'll notice. So x plus y, so 1 plus 7 greater than 4. And that gives you 8 is greater than 4. So that does check out, it's accurate. And then for the second one, 4 times 1 minus 7 for y less than -4. And if we simplify that one, we're going to get -3 is less than -4. And that is not true. -3 is greater than -4. So for that one, no. That is not a solution, the point 17. Okay, so if you try 3 and 4 on your own, for number 3, you should get that no, that is not a solution. And then for number 4, you should get yes. We're going to skip past getting started and go to Activity 6.1, just determining the better deal here. So we're going to analyze these two and compare them. So it says the Bicycle Company is planning to make a low-price, ultralight bicycle. There's 2 different plans to be considered for building this bicycle. The first plan includes a cost of $125,000 to design and build a prototype bicycle. The combined materials and labor costs for each bike made under the first plan will be $225. And then the second plan, I'm going to make this in red, includes a cost of $100,000 to design and build a prototype. And the combined materials and labor costs for each bike on this one was $275. So you recently got a job at Bicycling Company as a financial analyst. Analyze the cost for each proposed bicycle prototype and determine which plan Bicy should follow and provide evidence for your proposal. So what we're going to do is we're going to write the system of equations, and we're going to solve that. But then we're also going to go look at the graph using Desmos, and we're going to decide which one would be the better option depending on how many bicycles you choose. Okay, so for plan A, that equation we're looking at is y equals $125,000 for that starting fee plus 225 times the number of bicycles. And then plan B was $100,000 plus 275 times the number of bicycles. So if we wanted to solve that system, we could set those, substitute in for the y value, setting them equal to each other. And we're going to have 125,000 plus 225x equals 100,000 plus 275x. And we're going to solve that system. So I'm going to start by subtracting over the 225x. To move all my x's to the right, and I'm also going to then subtract this 100,000 to move that to the left, and that's going to end us up with 25,000 equals 50x. And then our final step, to solve for x, we're going to divide by 50. So we get x equals 500. So what that tells us is that 500 bicycles, they are going to be equal to each other as far as cost. Okay, that's the point where they're equal. So sometimes one's going to be a better deal depending on the number of bicycles. So we need to go take a look. All right, so next we need to know which one is the better deal depending on how many bicycles are going to be made. So we know 500 is that point where they're both making the same amount, or costing the same amount, I should say. So I'm going to pick a number that is bigger than 500 to start with. I'm going to pick, or well, let's use one that's less. We'll use 400, because we know at one point one of these plans is going to be better when you make more than 500. One's going to be better when you make less than 500. Since 500 is the point where they're crossing and they're equal to each other. So I'm going to pick 400 and plug it in for each one. So I'm going to plug 400 in for each one of these. And then we can simplify each one of those. So for that first one, 125,000 plus 225 times 400. And that comes out to be 215,000. This was plan A. And then for plan B, 100,000 plus 275 times 400. And that comes out to be 210,000. So what that tells us is that plan B is a better option if we're making less than 500, our even point where they intersect. But if we're making more than 500, that's going to mean that plan A is better. So plan B is better for less than 500, and plan A is better for more than 500. All right, moving on to 6.2. It says Demetrius is in search of a new cell phone plan. He's considering 2 different cell phone services from 2 different providers. Bouncing cell phone service offers a monthly fee of $99.99 and 2,000 megabytes of data per month. And once a user exceeds the free monthly data allowance, each additional megabyte of data use is 5 cents. And then rolling cell phone service offers a monthly fee of $79.99 and $1,500 in megabytes of data per month. Once the user exceeds the free monthly data allowance, each additional megabyte of data used is now 8 cents with the plan B. So Demetrius is unsure which plan to choose. He wasn't very careful with his last contract and paid a lot of extra money. So again, we're going to write 2 different equations. So the first one, this one was for bouncing cell. That equation, we have a starting point of $99.99 plus they're charging 5 cents times every minute you go, or every megabyte of data you go over 2,000. So we could say that total megabytes of data minus 2,000. That'll give us our total over 2,000. And then for the other company, Rolling Cell, that equation is y equals $79.99 plus 0.08. And that is charging you extra for every megabyte you go over 1,500. So the total megabytes minus 1,500. All right, so now let's solve this system of equations again, and let's find out that value of t again, where the point where their price is the same, where they're crossing again. So if I set them equal to each other, 99.99 plus 0.05 t minus 2,000 is equal to 79.99 plus 0.08 times t minus 1,500. I'm going to squeeze that in there. I'll make it a little bit bigger on the next line. So on each side there, we need to distribute first. So we're going to distribute here, and we're going to distribute there. So when we distribute the 0.05, we're going to get 0.05 t minus 0.05 times 2,000 gives you 100 equals 79.99, and then again distributing 0.08 t and then 0.08 times negative 1,500 give you negative 120. Okay, from there we can combine like terms on each side. So 99 minus 100 is going to give us negative 0.01. And 79.99 minus 120 is going to give us negative 40.01. So it's starting to look a little shorter. So then we need to get all our variables on one side. So I'm going to subtract 0.05t. And then I'm going to move all the constants to the left. So plus 40.01. And we're going to end up with 40 equals 0.03t. And then finally divide by 0.03. And we're going to get t. The total data where they're equal is 1,333.33. We'll round it to that. Okay, so that means that's the point where they both cost the same. So again, we could just take a value bigger or smaller than that. I'm going to say 1,000. And we could plug it in to each one of those and find out which is the better deal. So just like we did on the first example, I want you right now to pause it, plug in a value of your choosing. I suggested 1,000. So 1,000 would be less than that point, and find out which of the two options is the better amount if you are under that point where they're equal. And then that will also tell you which one is better when you're over that point. And then unpause it and see if we got the same answer. Okay, so you should have found that the bouncing cell is best if you're using more than the point where they're equal, more than the 1,333.33, which would mean that rolling cell is better if you're using less. Okay, again, you might have chosen different values, so I'm not going to work it out with a specific one, but again, we should have got bouncing cells best if we're over that point where they're equal, and rolling cells best if you're under that point where they're equal. All right, 6.3, solving a linear system of inequalities with 4 constraints. So sometimes we might have more than 2 inequalities. We could have 3, we could have 4. In this example, we're going to look at 4. So it says Miguel's eye doctor informed him that he needs glasses. Luckily, the local vision store is having a sale on all eyeglasses frames. The advertisement in the window is shown. Previously, you solved a system containing 2 linear inequalities. However, systems can consist of more than 2. Okay, so it says use the advertisement to write 2 inequalities that represent the regular price of eyeglass frames, that R represent the regular price. Well, the regular price is $120 to $360. So that means the regular price is greater than or equal to $120, but the regular price is also less than or equal to $360. Okay, then if we look at 2, we're going to do the same, but for this sale price. Well, the sale price, if it's 60% off, that means you're paying actually 40%, because 60 plus 40 gets to 100%. You're paying 40% of the previous price. So that means that our sale price is going to be greater than or equal to, and the lowest point off was 75%, so that would mean you're paying 25%, so 0.25 of the regular price. That would be the one constraint. And then our other one, like I mentioned, 0.4, 40%, we're going to be less than or equal to 40% of the regular price. So there would be another constraint. So it says Heather wrote this system of linear inequalities for the problem situation. Explain why it is not correct or why it is incorrect. Okay, what Heather did is a common mistake here. It's again just mixing up your percentages. If I'm saving 60%, I'm actually paying 40%. And if I'm saving 75%, I'm actually paying 25% of the original cost. You'll notice here on her second 2, she plugged in the 60% 0.6 and the 75% 0.75, which gives her not the sale price, it gives her how much she's saving, which is a different amount. All right, so if we go to the next page, we're going to graph that. So we're going to graph each inequality on this graph. So for the first one, and they're using, let's see, we got regular price as our x-axis. So if we look at our first two constraints, R is greater than or equal to 120 and R is less than or equal to 360. So we got vertical lines, because we're going through the x-axis, the regular price, so greater than or equal to 120. So we are on the right side of that line, and we are less than or equal to 360. So we're on the left side of that line if we're less than. So there's our first two. Okay, and then for the next one, S greater than or equal to 0.25 R. So think of it this way. If I rewrite that, S is greater than or equal to 0.25 R. That has a y-intercept of 0, so starting point is 0. And we got a slope of 0.25. Or to make it simple, we could just plug in a value and get a point for that. So if we plug in, let's say, I'm going to use 200 because that's a point on our graph. 200 for R. So 200 times 0.25, and that gives us 50. So we have a point of 200, comma 50. So that point would be here. So there's that line, and that's a greater than line, so we are above that line. And then the other inequality was S is less than or equal to 0.4 R. So S is less than or equal to 0.40 R, and again, plus 0, so we're starting at 0. And again, if I plug in, I'm going to use 200 again for that one. So 200 times 0.4 gives me 80. So 280 would be a point on that line. And that is a less than sign, so we are below that line. So if we're to the right of the blue line, above the green line, left of the red line, all our shaded overlap area is right in there. So there's our solution set. So shade the portion of the graph, we just did that. What shape does it make? I would say it looks like a trapezoid, right? We got a four-sided figure. It's a little tilted, so it's a trapezoid. And how much would Miguel expect to spend if he purchases eyeglasses that are regularly $320? Okay, well, if it's regularly $320, somewhere between here and there, anywhere in that range, looks like it would work. So I'd say that's between 80 and 120 approximately. That looks like the range he'd fall into. Then for 7, Miguel is definitely going to purchase a pair of eyeglasses that are on sale. What is the least amount of money he can expect to spend? Well, the least amount would be the very bottom corner of this possible range we are in. And that looks like we are at 30. So the least amount he could possibly pay would be $30. All right, and then to 8, Miguel decides on a pair of eyeglasses that are regularly priced at $240. Can Miguel expect to save more or less than $140 off the purchase price of this pair of eyeglasses? Use the graph to determine the approximate answer. So 240 is right there. So he's going to be in this range between here and here. So it looks like that's between 60 and 90 is what he's expected to pay, which means if you look at the original prices from 120 to 360, he's saving somewhere between let me rewrite that word, saving, there we go, between, if we take the top end 360 and subtract 90 and the bottom end 120 and subtract 60, he's saving somewhere between 130 and 180. Okay, and then I use algebra to determine the greatest amount of money Miguel can save by purchasing eyeglasses that are regularly $240. Well, if they're regularly $240, the greatest amount he could save is at 75% off. So 0.25 times the 240, because remember 75% off, we're paying actually 25%. So $60 would be his new price, which means if we take 240, subtract the 60, he is saving $180. All right, we're going to skip all the way past 6.4. We're going to end up here with talk the talk. One more example. It says the red cab company charges $3.50 upon entry, an additional $1.25 per mile. The yellow cab company charges $5 upon entry, and an additional $1.15 per mile. Emma needs to take a cab to the airport. Which company should she use if she wants to minimize cost? Okay, so again, we need to write our two equations. Y equals 3.5 plus $1.25 per mile. There's one equation. And then the yellow cab company, I should say this is our red and this is our yellow, is $5 upon entry plus $1.15 per mile. So again, we can set these equal to each other, substituting in for the y. And solve that equation. So again, I'm going to subtract 1.15x. I'm going to move all my x's to the left. And then I'm going to subtract 3.5 and move all my constants to the right. So 1.25 minus 1.15 will give me 0.10x. And then 5 minus 3.5 is going to give us 1.5. So then we can divide. And 1.5 divided by 0.1 gives us 15. So the point that the two costs are going to be equal is at 15 miles. So we need to figure out which one's better for going more or less. So let's pick a number smaller than that. Let's say 10. And I'm going to plug 10 in for each one. And I'm going to simplify that. 3.5 plus 1.25 times 10. And that's going to give us 16. So at 10 miles, that would cost $16. And then for the yellow cab company, if I plug in also 10 and simplify that one, that's going to cost me $16.50. So if we're going less than that point where they're even, if we're going less than the 15 miles, it looks like the red cab company is a better deal, which means if we are over the 15 miles she needs to travel, that means the yellow cab company would be the better deal.